Dark matter is massive. It is gravity, but it's invisible. It has no interactions with light or the electromagnetic force. For centuries, humanity has gazed into the cosmos, marveling at its vastness and complexity. Despite our advances in technology and understanding, one haunting truth has persisted. We still don't fully understand what makes up the majority of the universe. Ordinary matter, the stars, planets, and galaxies we see, makes up only about 5% of the universe. The other 95% remain shrouded in mystery, existing as what we call dark matter and dark energy. Now scientists have made a groundbreaking discovery, a new fifth force of nature that may finally explain these enigmatic phenomena and revolutionize our understanding of the cosmos. The universe, as we understand it, operates through four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. These forces dictate the behavior of matter and energy, from the motion of galaxies to the interactions of subatomic particles. For decades, physicists have sought a unified theory that could combine these forces into one cohesive framework. But what if there's a missing piece to the puzzle? A force so subtle and elusive that it has evaded detection until now. The idea of a fifth force isn't new. Theoretical physicists have speculated about its existence for years, hypothesizing that it might help explain the invisible mass that holds galaxies together, dark matter, and the mysterious force accelerating the universe's expansion, dark energy. But until recently, this was just speculation. That changed when a team of researchers at a prestigious laboratory made a discovery that could alter the trajectory of physics forever. The breakthrough came during a high-precision experiment designed to measure the interactions of fundamental particles. Researchers noticed subtle anomalies, deviations from predictions made by the standard model of particle physics. These deviations suggested that something new was influencing the particles, something that couldn't be explained by any of the known forces. At first, scientists were skeptical. After all, countless anomalies in experiments have turned out to be measurement errors or statistical flukes. But as the data piled up, the evidence for this mysterious force grew stronger. This new force appears to operate on scales far beyond the reach of conventional physics, interacting weakly with ordinary matter, but strongly enough to influence the structure of the universe. Its discovery is being hailed as a monumental step forward, not only in understanding dark matter and dark energy, but also in answering some of the most profound questions about existence itself. To grasp the significance of this discovery, let's first revisit the mysteries of dark matter and dark energy. Dark matter is an invisible substance that doesn't emit, absorb, or reflect light. We can't see it directly, but we know it exists because of its gravitational effects. Without dark matter, galaxies would fly apart. Its gravitational pull acts as a cosmic glue, holding galaxies together and shaping the large-scale structure of the universe. But dark matter is only part of the story. Dark energy is even more enigmatic. While dark matter pulls things together, dark energy pushes them apart. It's the force driving the accelerating expansion of the universe, a phenomenon first discovered in the late 1990s. Together, dark matter and dark energy account for 95% of the universe's total mass energy content, yet their true nature has remained elusive until now. The fifth force discovered by scientists appears to bridge the gap between these two cosmic mysteries. Early evidence suggests that this force may arise from interactions in a previously unknown field, one that permeates the entire universe. Some researchers are already calling it the dark field, a theoretical construct that could unite dark matter and dark energy under a single framework. If this is true, it would mark a paradigm shift in our understanding of the cosmos, akin to the revolutionary ideas of Newton and Einstein. But how does this fifth force work, and how did scientists detect it? The key lies in experiments using ultra-sensitive detectors capable of measuring minuscule forces at microscopic scales. These detectors, often cooled to near absolute zero to eliminate thermal noise, allow scientists to observe subtle interactions between particles that were previously undetectable. By studying these interactions, researchers uncovered evidence of a previously unknown mediator particle, dubbed the dark boson. The dark boson is unlike anything in the standard model. It is hypothesized to act as a carrier of the fifth force, much like photons mediate the electromagnetic force, and gluons mediate the strong nuclear force. But unlike these particles, the dark boson has properties that make it uniquely suited to interacting with dark matter and dark energy. For instance, it appears to operate at incredibly low energy scales, meaning its effects are only noticeable on cosmic scales. This aligns perfectly with the observed behavior of dark matter and dark energy. The discovery of the dark boson also raises fascinating questions about the origins of the universe. Some scientists speculate that this particle may have played a crucial role in the early moments after the Big Bang, influencing the distribution of matter and energy that gave rise to galaxies, stars, and planets. If this is true, then understanding the fifth force could shed light on the very genesis of the cosmos. But the implications don't stop there. The fifth force may also help resolve long-standing tensions in physics, such as the discrepancy between measurements of the Hubble constant, a value that describes the rate of the universe's expansion. Observations based on the cosmic microwave background suggest one value, while measurements of nearby galaxies suggest another. This inconsistency has puzzled physicists for years, but the fifth force could provide the missing link needed to reconcile these measurements. Beyond its theoretical significance, the discovery of the fifth force could have profound practical applications. Imagine harnessing this force to develop new technologies, from advanced propulsion systems for interstellar travel to revolutionary energy sources. The ability to manipulate the dark field could unlock capabilities we can't yet imagine, transforming science fiction into reality. Of course, as with any groundbreaking discovery, the emergence of the fifth force raises as many questions as it answers. For one, how does this force fit into the broader framework of physics? Does it represent a fifth pillar alongside the four forces, or is it part of an even more fundamental unifying principle? And what does it mean for our understanding of space, time, and reality itself? These questions are not merely academic. They strike at the heart of humanity's quest to understand its place in the universe. The fifth force challenges us to rethink the nature of reality, to consider the possibility that the universe is far stranger and more complex than we ever imagined. It invites us to confront the unknown and to embrace the mysteries that lie beyond the boundaries of current knowledge. As scientists continue to study this newfound force, they are already planning the next steps. High-energy particle colliders, like the Large Hadron Collider, are being repurposed to search for evidence of the dark boson in high-energy collisions. Meanwhile, astronomers are using cutting-edge telescopes to study the effects of the fifth force on the large-scale structure of the universe. By combining these approaches, researchers hope to build a comprehensive picture of how this force operates and what it reveals about the nature of existence. But the road ahead won't be easy. The fifth force is incredibly weak compared to the other forces, making it challenging to study directly. It also requires new theoretical frameworks to describe its behavior, frameworks that may push the boundaries of human understanding. Yet history has shown that humanity's greatest achievements often arise from confronting the unknown. The discovery of the fifth force is no exception. In many ways, the search for the fifth force represents a microcosm of science itself, a journey into the unknown, driven by curiosity and a relentless desire to uncover the truth. It is a testament to the power of human ingenuity and the boundless potential of the human mind. And as we stand on the brink of a new era in physics, one thing is certain: the discovery of the fifth force will forever change the way we see the universe and ourselves. This is not just a story about particles and forces. It is a story about humanity's unyielding quest to understand the cosmos, to unravel the mysteries of existence, and to find our place in the grand tapestry of reality. The fifth force is a reminder that the universe is still full of wonder, waiting to be discovered. The discovery of a fifth force of nature is not just a breakthrough in theoretical physics. It's a revelation that could upend everything we thought we knew about the cosmos. But to fully appreciate the magnitude of this discovery, we must delve deeper into its implications, its scientific underpinnings, and the potential future it promises to unlock. As scientists race to understand this mysterious force, they are uncovering new layers of complexity and beauty in the universe, each more mind-bending than the last. To begin, let's revisit how this force was discovered. At its core, the journey to the fifth force started with precision measurements of anomalies, tiny deviations from expected outcomes. These anomalies were found in experiments probing the interactions between subatomic particles. Such experiments are conducted using highly sensitive equipment designed to detect forces and interactions at scales unimaginably small to the human eye. Over time, as these experiments were repeated, patterns began to emerge, patterns that defied the predictions of the standard model of particle physics. This was an immediate red flag for physicists. The standard model has been the cornerstone of our understanding of fundamental particles and forces for decades. It has successfully explained the behavior of quarks, leptons, bosons, and the forces that govern them. But the standard model also has glaring gaps, most notably its inability to account for dark matter, dark energy, and gravity at quantum scales. These gaps have long suggested that the standard model is incomplete. The discovery of a fifth force may be the first step toward filling those gaps and building a more comprehensive understanding of reality. The anomalous results pointed toward the existence of an intermediary particle, the so-called dark boson. This particle is theorized to mediate interactions between the visible matter we know and the invisible dark matter that pervades the universe. Imagine a bridge that connects two islands previously thought to be completely separate. This is the role the dark boson could play in physics. By connecting the realm of visible matter to the mysterious domain of dark matter, it could offer insights into the true nature of the universe's hidden structure. One of the most intriguing aspects of the fifth force is its apparent universality. Unlike the other forces, which have specific ranges and strengths, the fifth force seems to operate on both microscopic and cosmic scales. This duality is unprecedented in physics and has profound implications. On the microscopic level, it could explain the behavior of particles that seem to communicate across vast distances through quantum entanglement. On the cosmic level, it could account for the distribution of dark matter in galaxies and the accelerating expansion of the universe, driven by dark energy. If the fifth force is indeed a unifying force, it could revolutionize our understanding of the universe's history. For example, consider the Big Bang, the cataclysmic event that gave birth to the universe. The fifth force may have played a crucial role in shaping the early universe, influencing the formation of matter and the structure of spacetime itself. Understanding this force could help us answer fundamental questions about the nature of time, space, and the origins of everything we see around us. The implications don't stop at cosmology. The fifth force could also have practical applications that border on the science-fictional. One of the most tantalizing possibilities is its potential role in advanced propulsion systems. If the fifth force can be harnessed, it might allow us to manipulate spacetime in unprecedented ways. Imagine spacecraft capable of traveling vast distances by surfing on the fabric of spacetime, bypassing the limitations of conventional propulsion methods. This could make interstellar travel a reality, opening the door to exploration of distant star systems and even the colonization of other planets. Another potential application lies in the realm of quantum computing. Quantum computers rely on the principles of quantum mechanics to perform calculations far beyond the capabilities of classical computers. The discovery of the fifth force could provide new insights into quantum phenomena, enabling the development of even more powerful quantum computing systems. These systems could revolutionize industries ranging from medicine and material science to finance and artificial intelligence. But the fifth force is not without its challenges. For one, its effects are incredibly subtle, making it difficult to study directly. This has led to debates within the scientific community about its existence and nature. Some physicists argue that the anomalies observed in experiments could be explained by more mundane factors, such as experimental errors or unaccounted for interactions. To address these concerns, researchers are conducting independent experiments to verify the results. If these experiments confirm the existence of the fifth force, it will mark a turning point in physics, akin to the discovery of electromagnetism or the realization that the Earth orbits the Sun. The discovery of the fifth force also raises profound philosophical questions. What does it mean for our understanding of reality? Are the forces we know simply manifestations of a deeper, more fundamental reality? Could there be even more forces waiting to be discovered, forces that operate beyond the limits of our current understanding? These questions challenge us to rethink our place in the universe and the nature of existence itself. One of the most exciting aspects of the fifth force is its potential to unify physics. For decades, physicists have sought a theory of everything, a single framework that can describe all the forces and particles in the universe. The discovery of the fifth force brings us closer to this goal by providing a potential link between the macroscopic and microscopic realms of physics. It could serve as the missing piece needed to reconcile general relativity, which describes gravity and the large-scale structure of the universe, with quantum mechanics, which governs the behavior of particles at the smallest scales. This unification could lead to breakthroughs that are difficult to even imagine. For instance, it might allow us to manipulate gravity in ways that were previously thought impossible, enabling the development of technologies like artificial gravity or gravity-based energy systems. It could also provide new methods for detecting and studying dark matter, shedding light on one of the most elusive components of the universe. As researchers continue to study the fifth force, they are also exploring its implications for the future of humanity. Some scientists believe that understanding this force could pave the way for a new era of scientific and technological advancement, one that could solve some of the most pressing challenges facing our species, from energy production and resource management to space exploration and planetary defense. The fifth force could be the key to unlocking a sustainable and prosperous future, but with great power comes great responsibility. The discovery of the fifth force also raises ethical and societal questions. How should this new knowledge be used? Who should have access to the technologies it enables? And how can we ensure that these advancements benefit all of humanity rather than a select few? These are questions that scientists, policymakers, and society as a whole must grapple with as we move forward. The journey to understanding the fifth force is just beginning, but it has already transformed our view of the universe. It has reminded us that the cosmos is far more complex and mysterious than we ever imagined, and that our quest for knowledge is far from over. As we stand on the brink of this new frontier, we are reminded of the words of the great physicist Richard Feynman. There is a pleasure in recognizing that the universe is bigger than we are, that we are not at the center of the universe. The discovery of the fifth force is a testament to the power of human curiosity and ingenuity. It is a reminder that no matter how much we think we know, there is always more to learn, more to discover, and more to understand. It is a call to explore, to question, and to dream of a future where the mysteries of the universe are unveiled, and the boundaries of human knowledge are pushed ever further. The discovery of a fifth force is not just an esoteric detail for physicists. It is a groundbreaking revelation with the potential to fundamentally reshape our understanding of the cosmos and our place in it. While we've touched on its scientific implications, let's take a deeper dive into what this could mean for humanity and the fabric of reality itself. First, let's consider the structure of the universe. For centuries, our understanding of the cosmos was built on the premise that only four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, govern everything we observe. These forces provided a framework for explaining phenomena ranging from the orbits of planets to the fusion of stars, and even the interactions of subatomic particles. But the discovery of a fifth force hints at an entirely new layer of complexity. This raises an intriguing possibility. What if the forces we observe are merely the surface of a much deeper and more intricate system? The fifth force may not only exist but also interact with dimensions or aspects of the universe we cannot yet perceive. In string theory, for instance, it is hypothesized that there are additional dimensions beyond the familiar three of space and one of time. Could the fifth force provide evidence for these dimensions? And if so, how could this change our understanding of reality itself? The fifth force could also lead to the unification of physics, the elusive theory of everything that scientists like Albert Einstein and Stephen Hawking pursued for much of their lives. Such a theory would reconcile the seemingly incompatible realms of general relativity, which governs the macroscopic world, and quantum mechanics, which governs the microscopic. The fifth force may serve as a bridge between these realms, offering a new framework that ties the gravitational force of planets and stars to the quantum behaviors of particles like electrons and quarks. But let's step back and explore what this might mean practically.